Good afternoon, everyone. Anyone who keeps learning stays young. The future belongs to those who learn more things and combine them in creative ways. With this, I, Tarun Jaiswal, Event Management Executive of the ACM Student Chapter, and your host for today, would like to thank you all for taking the time to join us. We hope you will find this session to be entertaining and insightful at the same time. Starting up is a conviction demanding decision that could be forced upon oneself. It's not always clear to a beginner whether he or she is on the right track, and doubts can be the worst limiters to our success. Without proper knowledge, we cannot aim to utilize our strengths to the maximum of our potential. Learning from experiences of an established person in the field could be a boon for anyone at any stage of a career. Machine learning is a valuable future technology and must be learned about. It can be the key to unlocking the value of corporate and customer data and enacting decisions that keep the company ahead of the competition. RGIPT ACM Student Chapter is proud to organize an exciting and informative workshop on machine learning by our esteemed guest speaker, Ms.Rupa Singh. Ms. Rupa has over 14 plus years of experience in IT and data analytics and has worked for large organizations across various domains. She's a machine learning and deep learning specialist and coach and the founder of AI Beehive. She's also the author of the book AI Ethics with Buddhist Perspective. She has provided more than 5,000 hours of training in machine learning to students and professionals. She is currently associated with upGrad as a coach in artificial intelligence. To impart us with the correct knowledge and to guide us through the experiences in the industry, we have a very esteemed guest with us with tremendous experience in the world of machine learning, a visionary and a very passionate person, Ms. Rupa Singh. The whole RGIPT family would like to present its heartiest greetings to her. So without any further ado, I would like to call Ms. Rupa Singh to share her insights and enlighten us with the world of machine learning. Over to you, ma'am.
Thank you so much, Tara. Am I audible?
Yes, ma'am, you're audible.
Okay, great. Thank you so much for inviting me, and thanks a lot for this great introduction. And it's a pleasure to be here. And first of all, I would like to thank all the participants who took time on Saturday afternoon. Most of you would have had lunch, or maybe some of you would have been waiting for the lunch, but you chose to join this session on machine learning, and I really want to thank you, while you could have been doing so many other things. So, and also I want to congratulate you because you chose to learn the most futuristic technology, that is data science and machine learning. Okay, so going ahead, so can I just have a response from you, just because you joined this session and you are looking for towards learning the future technology. So I truly believe that you guys are awesome. So can you just type in the chat window, I am awesome? Each one of you are awesome, whoever is present in this webinar. So I can see Anchal, Shrastha, Abhishek, Adarsh, Aditi, amazing, Ashar, Sudhanshu, great, awesome, Nipul, great, Divyansh, amazing, great. Thank you guys. And for those of you I could not take your name, but you all are, will be in my heart. Thank you so much. Great. Vasundhara, thank you. Thank you, guys. Okay, so I just want to know that how many of you have heard about machine learning and data science? And as you all know, this is the current buzzword, right? So have you heard about this, term, or on a scale of 1 to 10, 10 being the highest, what would you like to rate yourself? How much would you rate yourself on a scale of 1 to 10? 5. Grishma says 5. Okay. Awesome. 1. Okay. Great. Thank you for being honest. Thank you, Aditi, Divyansh. Amazing. Ashar. Yashank. Okay, great. So, all right. Thank you, guys. Thank you for your response. And I just love the participation. And thank you for all the energy and love that you guys are showing. And it's Saturday afternoon, and still you guys are so enthusiastic. I really love that. Okay, so just let me share my screen, and by the end of the session, I'm sure those who do not have any awareness about data science and machine learning, and who have any doubt in them, so that I will be able to clear. All right, great. So just let me share my screen. Please let me know if my screen is visible.
Yes, ma'am, it's visible.
Okay, great. So we are talking about the current buzzword, that is artificial intelligence. And I'm sure most of you have heard about this buzzword. It has been there for around for a decade, but it's more prominent in last 4 to 5 years. Okay, thank you, Sumit. Thank you, guys. You guys are still responding. So let me explain you what is machine learning. Okay, so machine learning and artificial intelligence, most of you that think that the AI and machine learning is just a synonymous terms, but it is not the synonymous terms. AI is an overarching umbrella, and machine learning is a subset of artificial intelligence. And deep learning is again a subset of machine learning. Okay, and data science encompasses all of these. Like data science, you have Python, you work with lots of data, you do data analysis, data processing, and data visualization. And once you have done all of this data science, you have done like statistics and maths, then comes the machine learning, and you create algorithms. Okay, and then deep learning is even a more a deeper subset of machine learning, which works on neural networking, and it works similar to the way our human minds work, human brain works. So these are very fascinating field. And then machine learning, we are going to see that how machine learning works. Okay, so since Tarun has already given my introduction, so I will not go ahead and take a lot of your time, but I'll just try to add some more points. That I am on the mission to impact more than 1 lakh students, 1 million students and professionals to achieve their goals, and who want to pursue their career in AI and machine learning. Okay, and I'm also the top 20 global AI leader, and currently mentioned in the as an expert member of Global AI Ethics Institute. And recently I published my book, that is AI Ethics with Buddhist Perspective. And if you can see this book, this is the book that currently have been published, and it's available in Amazon. Okay, so before we go ahead and learn about something, so these are the 3 elements that we need to succeed in our goals, like focus, commitment, and hard work. So if you agree with me on this, please write FCH in the chat window. Amazing. Thank you, guys. Thank you, Tarun, Yashang, Aditi, Divyanshu. Thank you so much. So there are lots of things we start at the at the beginning. We all are very excited about whatever we are starting. For example, somebody wants to reduce their weight and decides to go to gym every day. But initially we are all excited and go to gym. But eventually what happens that we lose our commitment and we lose focus, and we start and we stop giving up on our goals and dreams. And but what I want to say is that if you really want to succeed and if you want to learn something, then what is required is focus, commitment, and hard work. And the most important thing is consistency. Okay, so you might have decided to learn a lot of things but would have left in between. But if you want to get into data science and machine learning, commitment and hard work is must. Okay, so according to this Davenport and DJ Patil from Harvard Business Review, and they suggested that data science is the sexiest job of the 21st century. And I'm sure all of you want to get into this, would like to get into this field and become the most sexiest, professional of the 21st century. And why it is called like that, we are going to see in detail. So what is machine learning? So it is a subfield of artificial intelligence which enables machines to learn from past data or experiences without being explicitly programmed. So this is a very, lot of jargons and a definition given by Arthur Samuel. So, but what does that actually mean? So, the machine learning, for example, if we do any coding, everything that we do, whether we, write or send a message in the in our mobile, or write a comment in our social media feed or Facebook or LinkedIn, or we do anything, it is all done by coding, right? But in the field of machine learning, we do not need to write the entire code, but we just have to give them we just have to give machines millions amount of data, and the machine learns from the data itself. It just works like maybe you will have small kids in your house, and you want to teach the small kid that whether it is a cat or a cow, so you show them this is a cat or this is a cow, and next time a new cat or a cow comes, so they're able to identify that. Yeah,
Ma'am, your voice is not clear. It's breaking in between, so you can.
It's breaking in between. Am I audible now?
Yes, ma'am, it's not clear.
Okay. Is it same for everyone? Okay, it's audible. Okay. Okay, now is it fine? Can I proceed?
Yes, ma'am, it's fine.
Okay, great. Thank you. Okay, so in order to understand machine learning, I'll just give you an example of bait shyness. So this is a rat, and one fine day you find this rat in entering into your house from the backyard of your house and coming into your kitchen. So you find this rat and you get really disturbed by looking at this rat, because you know that the kind of damage it is going to do in your kitchen or wardrobe. So what you decide is you take a favorite fruit, a favorite sweet from your fridge, and you decided to mix some rat poison and keep it in the side of the kitchen, and thinking that the rat would eat. So you left after keeping the sweet in the kitchen, and you went and you just slept in the night. So early morning when you got up, the sweet is lying as it is, and the rat has not eaten it. So can anyone tell me that why the rat would not have eaten this sweet? Any guesses? Any guesses that why the rat has not eaten the sweet? You can interact, you can unmute yourself and talk. Any idea? Yes, no? Yes, guys. Okay. Okay, fine. So why the rat has not eaten this food? Because it has already had previous experience with this kind of food. Okay, the rat was not hungry. Okay, so it has already had this previous experience. When the rat had eaten this kind of food, it had ill effect on its body and its mind. So next time when you presented this kind of food, rat had already recognized this food with, associated this food with danger. So it decided not to eat this. So as we can see that even the animals take decisions from the past data, and we humans always take decisions. Most of the decisions are based on the past data, whether you want to go out and play cricket by looking at the cloud, or whether you decide to go to a particular restaurant or go to a friend's house. So it all depends upon your past experience, right? And this is how the machine learning works. Based on past experience, it predicts the future. So the catalyst for the growth of artificial intelligence. So can you write down the catalyst, the four major reasons for the growth of artificial intelligence? Please type in the chat window. That is increase. Great, awesome. Yes, data. Yes, so there's a lot of data, big data, availability of exploding volumes of data, then increased computational efficiency, and sharing and storing of the data has become really affordable and cheap, and then improved algorithms and open source. So it's all of these factors has accelerated the growth of artificial intelligence. Yes, that's great. Great. Personalization. Yes, so our world is now, the more and more our world is becoming digital, the more data that we are creating through our mobile app, through mobile, through internet and social media, and every action that we are taking is generating data. So even now we all are generating data, by coming to this webinar, and the data is that how many students have how many participants have come and attended this webinar, or how many participants came and left, or how many participants continued till the end. So all of this is generating data, and whether we agree, whether we like it or not like it, but we are already a part of machine learning and AI systems, and we cannot escape it. Okay, so, and the computational efficiency has grown exponentially from the past few decades. And then we have, because of cloud computing and internet, there is a lot of there much affordable and cheaply storage and sharing devices that has come up. And then improved algorithms, improved machine learning algorithms, deep learning algorithms. All this has multiplied the growth of artificial intelligence. So as you can see here, this is the ocean of data and the kind of data that is being produced every minute. For Facebook, it produces like more than 30 million data every minute. And then YouTube, all these data, all these applications are producing these many data, millions and billions of data every single minute. So when you are posting your photographs or liking somebody's post, or whether you are watching Netflix videos, YouTube videos, or taking a cab or ordering food from a restaurant, every action that we are doing is generating data. And then through our mobile applications, as well as through the IoT and sensors, and all these things are, creating, exploding volumes of data. And these data are, okay, can anyone tell me that what are the kinds of data that we have? Any idea the kinds of data that we have? Please type in the chat window. Nominal, okay. Discrete data, visual data, okay, great. Amazing. Awesome. Continuous data, great. Thank you, everyone. Thank you for your answers. So this can be broadly classified into structured and unstructured data, right? So what is structured data? So all our data contains, it is in the form of structured data and unstructured data. And most of the data, like 80 to 90% of the data that is available is in the form of unstructured data, which is audio, video, text, or images. And all of this has to be converted into processed and converted into meaningful information. So the companies that having our data is just like having a Ferrari, and if they're not able to use the data, the kind of data that they're generating, it is just like having a Ferrari but not able to use it. And it is also said that data is the new oil. Okay, and okay, so currently we are all in the web of machine learning with personal assistants, Siri, Alexa, Google Home, Amazon Echo, and then we have recommendation systems that that is being used by Amazon, Netflix, YouTube, Twitter, Flipkart, and so on. So how does Amazon or Netflix uses AI in their systems? So for example, if you're watching certain kind of web series, maybe a comedy web series, so Netflix knows that you are interested in comedy web series, and then there are many people who are interested in similar kind of web series, so they create a cluster, grouping these people together and then giving them, so next time whenever a new comedy web series comes in, so they show them the ad and recommend these new web series to all the people in that particular cluster. So another, maybe somebody is more interested in series like Discovery channels, or more interested in animal movies, or maybe movies of robotic systems. So they again form a different clusters and give them the recommendation based on that. So similarly, Amazon and YouTube, they do the same thing. So Amazon, For example, if you are buying certain kind of products, if you're interested in electronic goods, or maybe you're interested in buying a particular kind of brand, so it already knows your preferences and choices, and based on these systems, based on your historical record, like what kind of products that you are buying, so it has gathered all of your data, and then it can easily predict that this is the next item that you are likely going to buy. So even the prediction systems are so useful that, for example, if you are a college student, so based on your historical data, they can easily predict that how much score that you are going to get even before you have written the examination. So this is the predictive power of machine learning. Okay, so how does machine learning works? So as we said that it does not need to explicitly program the coding. It does not need explicitly programming machine learning systems. For example, if you want the machine learning to recognize this image of a cat is a cat, so what we do is we give machines millions amount of data, or millions amount of images of cat, and then machine learns from this data itself, and next time you present a new image of a cat, so it knows that this image of a cat is a cat. Okay, so now working with supervised learning models. So in machine learning, there is not one technique, but there are variety of techniques that forms the machine learning cluster. For example, you have supervised learning, unsupervised learning, and then you have reinforcement learning. So and 90% of the work in industry is based on the supervised learning model. Okay, so how does it work? For example, supervised learning model contains label data and target data. So it has already known label data. For example, you have lots of images. So one image is a cat. You have already classified that this image is a cat, this image is a dog. And next time you present the image to the machine learning model, it knows that this is a cat or a dog. So here, if you are presenting these geometrical patterns, right? So these are the geometrical patterns that you want the machine learning to know that what is this pattern called. So here these are the labels that has been given here. This is a circle, star, and triangle. So these are the labels you have created. It is created manually most of the times, and then we give this model, we train this model by using these data, and then there is a test data which is used to test that how our model is performing. And after the test data is the model is tested with the test data, it shows that this is the circle and this is the star. So if it is able to correctly identify that with the test data, it is able to correctly identify, then we say that our model is performing well. And most of the time, it is more than 80% of accuracy is required. Again, it depends upon different business cases, different domains that we are working, that how much is the accuracy and precision that is needed for the machine learning models. Okay, so till now it's clear. Any question, any doubt? Yes, guys, you need to interact. Okay, amazing. Great. Thank you, Divyansh, Satpal, Gaurav. Yes, Gaurav, please tell me. You can unmute yourself.
You guys can ask the question in chat, or if you want to unmute, you can.
Okay, guys, for feature engineering and all of that, we are not getting into detail right now because this is a introductory session. So for feature engineering, maybe we have to, get into next sessions. We have to create more sessions for this. Okay, great. Okay. So, like AI can make a prediction, so it can also be used to alter the privacy. Yes, yes, Yashraj. So there are lots of privacy issues, data privacy issues, and so it all comes under the AI ethics and data governance, and these are the challenges of AI, since there's all of the data are being collected and used by organizations. So there is lots of data privacy challenges, but there is also GDPR rules and GDPR policies that is being utilized, and there are few countries which are very strict in applying GDPR rules, but still there is a lot of scope for improvement. Okay. We have seen concept of deep learning used in driverless car. Where can we use this concept in other scenario? Okay. Yes, so deep learning can be used in healthcare also. For example, to detect whether the person has the cancer or not, or detecting the whether the person has brain tumor or not, while checking on all the when they have all the images of the brain tumor or the cancer images. So and somebody and a new image has been given to the deep learning models, so it can predict that whether the person has a cancer or not. So it is also not only for the self-driving cars, but it is also used for healthcare and for financial industry also, for finding out credit card frauds and anomaly detection. So deep learning can be utilized in any industry and any domain, including healthcare, finance, and automation for manufacturing industries. Okay. Great. So the types of machine learning we have are supervised learning, unsupervised learning, and reinforcement learning. And supervised learning, the main difference between supervised learning and unsupervised learning is that supervised learning models have label data and target data. Okay, so you already know that what you're going to predict. Okay, just a second. For machine learning algorithm, we provide with handcrafted features. For deep learning, features are selected automatically. Yeah. Okay, so for supervised learning, we have label data and target data, and we already know that what we are going to predict. For example, if you want to predict whether an email is a spam or not, so first, when you have an email, the list of emails, maybe thousands of email that has been categorized to a spam email or non-spam email. So next time when a new email comes, so with the help of supervised learning model, they can easily predict that it is a spam email or non-spam email. Okay, so similarly and supervised learning models have regression and classification techniques. So regression is, okay, can anyone answer me what is the difference between regression and classification? Regression and classification models? Any idea? or any example, discrete data set in classification. Okay, great. Yes, so supervised machine learning, perfect. Yes, Alia, continuous in regression. So supervised machine learning model has continuous, sorry, regression and classification. And regression uses continuous data. For example, the numerical data. Whether if you want to predict the marks of the student or weight of the people, or maybe the cost of certain items, or the salary of the employees. So all of these numerical data that you predict is falls under regression analysis, regression methods. And the classification is maybe like, yes, it is also called for discrete data. For example, whether the email is spam or not, or whether it is for weather prediction, whether it is going to rain, or it's going to be dry, or no rain, or cold, or hot, or summer. So all of this comes into classification model. Okay, and unsupervised learning, which does not have any label data. So it is used to find out anomaly detection, and it is used for clustering. For example, the items with similar attributes. For example, maybe if you look at the food items, if you have potatoes, that will form a one cluster, and tomatoes will form another cluster, then rice, and then wheat, or vegetables. All of these will form another clusters. And if they don't know, or if the label has not been defined, so that comes under unsupervised learning. Okay, and it is also used in finding anomaly detection. For example, one of the application that we can find out in credit card fraud detection. So with the help of unsupervised learning, anomaly detection, we can easily find out that this particular transaction is a deviation from the normal transaction that a person does. Maybe the person does a similar kind of transaction, or maybe the person is based in India or in some other country, but the transaction is done in different country at the same time. So since there is an anomaly, it can be easily find out that there is the fraud that is happening. And it has a lot of use case in financial industry. And then what is reinforcement learning? Reinforcement learning is mostly used as, for example, you all would have learned how to ride a bicycle, or maybe a lot of you would have learned how to swim, right? So it just works on the similar methods, reinforcement learning. So it works by making mistakes and maximizing the reward systems. So when you once you first start learning cycling, so you would fall a couple of times, and next time you would know that, okay, this is how I'm falling, or this is how I need to improve, or I need to pedal, and then this is how you improve and learn cycling. And this is how the reinforcement learning works. And it is mostly used for robotic systems, or the products such as vacuum cleaners, or even for self-driving cars. Reinforcement learnings are quite used. Okay, so and that machine learning life cycle. So the machine learning life cycle, it always starts with business understanding. And most of the people, they if they want to create machine learning models, they straight away jump into creating algorithms, without understanding without having an understanding of business. And so the first important question is that what you are trying to achieve from your uh, business understanding. What is the actual problem that you are trying to solve? So once you have business understanding and awareness about the kind of problem that you're going to solve, so you create you collect data based on the kind of problem that you're going to solve. Okay, so for example, you want to understand, and Amazon releases a new product, and you want to understand, so this product will be used by maybe kids or adults or the old age people, or maybe in which country this product will be used, or for which demographic. For example, what is the education or qualification of the people who are going to buy this product. So based on that, you need to start collecting data, and this is how data collection process comes into picture. And not all the data is important, but the relevant data that we are talking about. Okay, and once you have collected all the data, then the data preparation work goes into this stage where we do feature engineering and feature selection and data preparation, like data cleaning, data wrangling. All this comes under data preparation, and creating descriptive statistics and inferential statistics. So once all of that is done, we create models, and the model is evaluated using different techniques, such as cross validation and cross validation techniques and other techniques, and then the model deployment is done. So this is an iterative process. So every time, as and when you get data, it doesn't stop here. So it does not mean that once you are done with the model deployment, so our work gets stopped. So every time the new data comes, and the cycle keeps repeating, and there is always, it is improving. Okay. So the ingredients of data science is extraction, preparation, analysis, visualization, and maintenance. So yes, and data visualization also plays a very important role. So you cannot be a good data scientist if you lack the visualization, data visualization, because a lot of people, what they do is they would be very good in data cleaning part, very good at descriptive analysis, inferential statistics, inferential analysis, and but if they're not able to do the visualization and communicate their data effectively to their stakeholders, to their customers, so we are not doing a justice being a data scientist. So that is the most important. However, it is very much overlooked part of data science, where people do not focus on communicating the data and visualizing the data effectively. Okay, so, and then data maintenance. Okay, so how many of you think it is, you're enjoying the webinar or you're learning the webinar? If you are learning, then please type in the chat window yes. And if you have any question, please let me. Amazing. Thank you. Thank you, Tarun, Anchal, Gaurav, Jayprabha, Alia. Okay, great. Amazing. Any question? Aman, thank you so much. Great. Great.
We are not audible.
Sorry. Am I audible now?
Yes, ma'am.
Okay, great. Thank you. Just a second. Okay, yes. So we have descriptive analytics, analysis, prescriptive analysis, predictive analysis, historical analysis, and all these analysis comes into picture. And the most important is prescript. So descriptive analysis is once you have all these data and you want to just analyze that what has happened in the past, that is called descriptive analysis. Okay, so when you, and then predictive analysis is where you want to predict. So since you have descriptive analysis, you already have described your data. So earlier in the traditional form, in the organization or institutions, what used to happen is people only used to analyze the people only used to do descriptive analysis. Okay, just having, now they have all the data and then they decide, they just analyze those data. For example, in college scenario, if a particular department, suppose a mechanical department scores better than computer science department. So in one of the semester, okay, or maybe the girls are doing better in one particular subject, or suppose basic electrical engineering. So if the girls have performed better than boys in one of the department, so these are the descriptive analysis that we do. Okay, or in organization, for example, the sales of that particular product was maybe $100 million in last quarter, or it did not perform well in the next quarter, or it did not perform well, most of the people did not buy from a particular region. So these are the descriptive analysis. Okay, but if you want to predict, for example, if a company has introduced a new AC machine and it wants to know based on this past data that how many sales, AC sales would happen during the next summer. So this is the predictive analysis. Based on the past historical data, it makes a prediction. Okay, and what is a prescriptive analysis is, so for example, in the hiring scenario in HR department, you must have heard about that, a lot of people are resigning. There is a great resignation that is going on. So if, and most of the organizations are suffering from that. They are currently struggling with lots of hiring and hiring and resignation process. So prescriptive analysis, what happens is once they know, the HR department, the organization know that the person is going to leave the organization, and with data analysis in the HR business, they can already know that person is, even before they have done the resignation, they can know that the person is about to resign. So this is called people analytics. Here also plays data analysis. Data analytics plays a very important role. Okay, so based on their interaction, so there are a lot of different parameters, KPIs, key performance matrix. So a lot of parameters that decide, that can tell that the employees are going to leave, whether the way they are engaging with other employees, the how much amount of sick leave that they are taking, the engagement of their work, engagement in their work, participation in meetings, and their distance from their home. So all of these factors into or their appraisal systems, definitely. So all of these systems, all of these attributes, they can predict that whether an employee is about to leave or not, even before the employee himself or herself has decided. Okay, so So prescriptive analysis, where it comes that when they know it and they give certain offers to the employees, whether they give them on-site opportunities, or they give a pay raise, or they give them better benefits. So this is how the prescriptive analysis works. Okay, so is that clear? Amazing. So the real-time opportunities for business. Okay, thanks, Vinita. So the real-time opportunities for businesses are into product, processes, and insights. So product, as we already know, that Siri and Alexa that we talk to, these are the products of machine learning and AI. And then robotic systems, vacuum cleaner, the self-driving cars, and also the General Motors is planning to introduce a new car, introducing computer vision, and not to watch the roads, but to watch you, that is the driver, and alerting the driver if they're sleeping, or if they're drowsy, or if they're not paying enough attention on the road. So this is how AI is revolutionizing the current industry. And then processes, then AI processes, machine learning and AI enabled processes are helping organizations to streamline their work, the redundant work, or for managing the task and assigning the task. So all of this is making more convenient, faster, and more accurate while applying AI and machine learning. And then for insights, as we talked about, that how Amazon and Netflix are using machine learning predictions, machine learning recommendation systems. For example, Intel is using machine learning prediction systems to improve their sales and revenue, and by analyzing their customer and creating tailor-made or customized ads to target to the customers. And this is how all the other platforms are doing. They create tailor-made products, tailor-made ads, customized ads, and they target to their customers to increase their sales and revenue. Okay.
You're not audible.
Okay, I'm sorry. So, okay, am I audible now?
Yes, ma'am.
So how many of you would be interested in learning machine, getting into this field of machine learning and data science? Please raise your hand or say me. Okay, great. Ashar, Tarun, awesome. Great. Amazing. Great. That's really fantastic, guys, because this is the best decision that you can take. And machine learning and data science is just going to be like a mandatory skill set. It's just like English and mathematics that we need to know. It will be just like the machine learning and data science is going to be like that in coming times. And the sooner you get into this field, the better it would be. And I also see that the students, 9-year students and 10-year students, they are also learning machine learning. And there was one of the session I took for them, and I had to teach them AI ethics. And I was really surprised by the kind of examples that they were coming with. So, and it was really surprising and astonishing that these 9-year-old kids and 9 years to 15 years old kids, they were learning machine learning, and they were giving great examples about AI ethics. While most of the adults are, they are very much intimidated by this machine learning and data science. Okay, so the roadmap that I would like to suggest is first you need to learn Python, and then Python for data science, then maths, and okay. Can you just let me know how many of you have coding experience? Okay, Alia. Great. Amazing. How much would you like to rate yourself in Python or coding from on a scale of 1 to 10? 4, 5. Okay, not bad. Amazing. And how many of you do not have any experience in coding, or you are scared about coding? Just write down no. Okay. Okay, great. Thank you for being so honest, guys. So, and as some of you, those who know about Python, you might have experienced that Python is really easy to learn. It is not like C or C++ with, hundreds of coding, lines of code, but it's very much like English or if you know basic English and basic maths, you can easily learn Python. Okay, and then the maths for data science is also not very tough. It's a very simple maths, whatever you would have learned in 11th standard or maybe even 9th or 10th standard. And then we have statistics, and we need to learn about descriptive statistics, that is mean, median, mode, and all of that. And then inferential statistics, that is a little bit tricky, where you know about confidence interval, hypothesis testing, p-value, and all of these aspects. And then once we have learned all of this, then we do exploratory data analysis, and then we get into creating machine learning models, like supervised learning models and unsupervised learning model, and then we have model deployment. Okay. So if you really want to get into this machine learning field, it might take you 5 to 6 months with a lot of focus. Okay. So the rare qualities of data scientists and are they try to find order and meaning from the and value in unstructured data. They can predict outcomes and automate processes. And the example is like AI chatbots is also one of the example of data science. Okay, and okay, so this is the data science hierarchy. If you look at the roles of data engineer and data scientist, so these are the tasks that is being performed by data engineers, like collection of data from external data sources, sensors, logs, user-generated contents, and working with lots of collection of data and processing of structured and unstructured data. So the data that we have contains a lot of impurity, lot of missing data, and that requires data cleaning and filling the data sets and removing certain outliers or certain data which is not relevant to our business problems. Okay, so all of these comes under data engineer. And for data scientists, then it comes to data pre-processing steps, like encoding categorical data, splitting training and test data, feature scaling, feature engineering, and then applying machine learning algorithms, evaluation, cross-validation, then confusion matrix, and so on. And then working on AI, deep learning, computer vision, NLP, and all of this comes under data scientists, and then doing a lot of research work. Okay. So the average salary of data scientists is like more than $100,000, and And then, yeah, these are the data science jobs are really leading all the other jobs in the industry right now, and so it has, providing a good handsome salary. So the this is the graph by Glassdoor. Glassdoor has predicted that, Glassdoor has, given that data scientist jobs, they get more than $118,000 annually. Okay, and these are some of the advantages of machine learning. And for supervised learning, we have classification and regression, where classification is used for diagnostics of different diseases, and whether the person has heart disease or the diabetes or not, or whether the person has cancer or not. So all of these comes under classification analysis. And then customer retention, whether the customer is for a telecom industry, telecom service provider, and they can know whether the particular customer is about to leave their services, or they want to continue their services. And then image classification, fraud detection, or whether the person should get loan or should be rejected from loan. Okay, and for regression, we have effective cash management, weather forecasting, and market trends, estimating life expectancy, and adding value for clients. So all of these comes under regression analysis. Then unsupervised machine learning, we have dimensionality reduction, that is meaningful compression, big data visualization, and all of that. And then clustering is used for recommender systems, customer segmentations, and targeted marketing, which is mostly used by companies like Amazon, Netflix, YouTube, or Facebook. So they mostly use this unsupervised machine learning or clustering techniques. And for reinforcement learning, is used in AI games, robot navigation, skill acquisition, learning tasks, and all of that. Okay, so can you give an example of a clustering technique from your experience? Anyone, can you give an explanation? Can you give an example, or all of you can type any example of whether for supervised machine learning or for regression or classification, or you just pick any one and just write in the chat window. Just think of any of the experience, or you might have come across grouping traits from face images. Okay, amazing. Regression, weather prediction, great. Grishma, awesome. Great. Thank you, guys. Thank you for your responses. Fruit classification, amazing. Yes, for fruit classification, great. Okay, so now comes DIKW framework. What is DIKW framework? Any idea what is DIKW? Any idea what is DIKW? Any guesses? D for data, okay. Yes. Data, amazing. Yes. S, what is the full form? What is the full name? Great. Amazing. Yes. So that is data information knowledge and wisdom. Okay, so this is the DIKW framework, and so data itself is not very valuable because it contains a lot of impurities, lots of structured and unstructured data, and data itself is not of any value until and unless it is processed in or it is organized. So it's just like junk data, and it does not make any use if it is not processed and if it is not organized. So once the data is organized, then it becomes an information. So for example, based on the organized data, you know that for a particular month, how much was the sales, or in particular country-wise, how many people maybe were affected by COVID, right? So these are the information. So once they know that how many people were affected by COVID, then they try to make knowledge out of it, that okay, for example, a particular state or particular country had more number of COVID patient than another country like PQR or ABC. So now this makes an information. And what is wisdom is that when you use these knowledge and information to make a useful outcome, that okay, so now you know that there are so many people who are suffering from COVID or any other problem. So what can we actually do to help these people? Or how can we use the prescriptive analysis? So that is the wisdom. Okay, so is it clear? DIKW, is that clear, this framework? Because I'm going to ask you one question based on this framework. Please type in the chat window if it is clear or if you have any question. Okay, amazing. Thank you, Aman, S, Alia, Tarun, Devyansh. Great. Thank you, guys. Okay, so this is the question for you guys. Just a second, I'm not able to change it. Okay, so can you just answer this question? Or if anyone wants to read this question, you can unmute yourself and somebody can answer this question. Tarun, would you read this question?